This should be just a review of some stuff, for the most part, about square roots. Square root of a number is a number that when multiplied by itself gives you the original number. That's the definition of a square root. So the square roots, plural, of 16 are plus and minus 4, because in both cases 4 times 4 is 16 and negative 4 times negative 4 is 16. If we only want the positive square root of a number, we use this sign, which is the radical sign. That is a radical sign. Yes. What do you normally think of when you think of something as being radical?
Like cool. Yeah, like rad, you know.
Okay. So yeah. So before skateboarder culture and the like took it over, radical meant weird, different, strange. Okay? If someone has radical political views, their political views are way outside of what everybody else thinks.
Oh, so like a terrorist group.
Correct. They have radical views. Yeah. Okay? So when mathematicians first started thinking about things like square roots, most mathematicians didn't believe there was anything other than whole numbers, decimals, and fractions. The square root of 3 is none of those. But mathematicians at the time, the established ones did not want to accept it. The Pythagoreans in particular, were mean to people who had this idea, and they called them radicals.
Isn't it the Pythagorean theorem that has the squared in the first place?
Yeah.
They just didn't like it opposite.
Yes. Yes. So this stands for the principal square root, although we usually just say the square root. So when the principal square root of a number is a whole number, the original number is a perfect square. Why is that? Why do we say that 36 is a perfect square? Because we can make a square whose area is 36 and its sides will be whole numbers. So 36 is a perfect square. If you make a square with an area of 20, its sides aren't going to be whole numbers. So it's not a perfect square. So that's why those numbers are called perfect squares. You should memorize some perfect squares. I don't know how many you know, but it may not be enough. I would suggest at the very least you know through 16 squared, which is 256.
Oh, I know through 100.
You know what?
Oh, wait, I think I know through 12.
I think I know through at least 20, I think. But
So that's 16 squared, 17 squared, 18 squared, 19 squared, 20 squared, 21 squared, etc. It comes in handy to know those since you are going to be doing this unit without a calculator. So, how do you simplify square roots? You have done this before. I think in Algebra 1, but I'm not positive.
we learned a bunch of this stuff.
There's a whole bunch of different ways you can do it. And I'm not sure which way you did it. There are the two primary ways.
We did number 1.
Yeah.
Perfect square factorization?
We did both. We learned both.
Okay.
We didn't fully learn prime factorization.
Well,
Okay. So, all right. Let's not bicker about that. So, perfect square factorization is always the faster way to do things. If you can think of the biggest perfect square that divides evenly into the number under the square root sign. If you can do that, that's the fastest way. Okay? If you can't do it, what we'll do is we'll divide the number, in this case 700, up by prime numbers. Remember, prime numbers are numbers that are only divisible by two things, themselves and also 1. So that's going to be 2, 3, 5, 7, 11, 13, 17, etc. So if we divide this up, notice I've got 2 2's, 2 5's, and a 7. 2 2's, 2 5's, and a 7. The square root of 700 is the square root of 2 times the square root of 2 times the square root of 5 times the square root of 5 times the square root of 7. by definition, the square root of 2 times the square root of 2 is 2. The square root of a number is the number that when multiplied times itself gives you the original number. So the square root of 2 times the square root of 2 is 2. And the square root of 5 times the square root of 5 is 5. You probably, in algebra, I don't know, but you probably did something like that. You circled these, yes?
Yes.
And went, okay, that's going to be 2. And this is going to be 5. And everything that's left over is left under the square root sign.
Yes.
Okay? So let's simplify these. We're going to zip through these pretty quickly.
We should have done the tree.
Yes, that we learned.
Oh,
that-
yeah, that's
Oh,
right.
by
in fifth
doing it
grade,
with the
we
tree?
learned the tree.
Yeah.
That's what I was gonna say.
The only reason I don't do the tree personally is, although sometimes it's faster, I'll agree with that. The problem is if it doesn't end up where all branches of the tree come down to the same level, it's easy to lose one.
That makes sense.
That's the only reason I don't do it that way. Now, personally, I do perfect square factorization as often as possible. So like here, what's a perfect square that'll divide evenly into 45?
9.
9. And although I don't always take the time to write it, that's the square root of 9 times the square root of 5, and the square root of 9 is 3. Now, when you get a number like the square root of 147, most people can't immediately think of, well, what perfect square goes evenly into that? So this is a good case for prime factoring. What is a number that'll divide? And I actually, yeah. Will 3 divide into that evenly?
Yeah.
Yeah, because 1 plus 4 is 5 plus 7 is 12.
Okay. So 3 goes into this 4 times with 2 left over. That's going to be 49. 7 goes into that 7 times. I personally would have started with 7 because 147 is pretty obviously divisible by 7. I try to think of bigger prime numbers. So that'll be the square root of 7 times the square root of 7 is 7, and we have a square root of 3 still left.
Wait, why'd you put 7 on the outside of the 7?
Because I divided 7 by 7. You divide it until you get down to 1.
Okay.
Some people do it up. I do it down because if you do it up, the problem is you got to make sure you got room on your paper to get all the way to the end.
Wait.
So 7 goes into 49 7 times, and 7 goes into 7
So you
once.
just do it until you get a prime number, or a,
You do it until you get 1.
but like how do you know when to stop?
When you get 1.
No, like couldn't you just do 147 divided by 147?
It has to be a prime number. 147 is not a prime number.
On the outside, it has to say prime numbers.
You have to divide by a prime number, and 147 is not a prime number.
So you just stop when you get to a prime number and then divide by that and get 1.
I mean,
Okay,
yeah.
yes, I see what you're saying. Yes.
Okay.
I just say you divide until you get 1.
I remember.
All right. So the square root of 180. Can you think of a perfect square?
36.
36, nice.
Gosh.
Square root of 36 times the square root of 5. So this is 6 square roots of 5. Now, what if you didn't think of that immediately? We can do prime factorization. What's a prime number that divides evenly into 180?
9.
9's not a prime number.
Oh, wait.
So good.
How about 2? That's easy. I'm good at dividing by 2. That's 90. 2 goes into 90 45 times. I tend to stick with whatever prime number I started with for as long as I can so that they're together.
That makes sense.
Pardon? 3? Okay. 3 goes into that 15 times. 3 goes into 15 5 times. 5 goes into 5 once. So I've got 2 times 3 times a square root of 5 that's left What's left over is left under the square root sign, so that's 6 square roots of 5. When you get something like the square root of 216, again, it's unlikely that you're going to be able to just go, oh, I know that this is this perfect square times this other number. I happen to know this one, but most people probably don't. So we can start either with what or what?
2
Or
or
6 isn't prime.
I mean,
3.
3.
So let's go 3, right? 'Cause it's
Yeah, I usually start with 3 if I can because it's bigger. That's 72. Then it makes what I'm dividing into smaller quicker. 3 goes into 7 twice with 1 left over. 3 into 12 goes 4 times. I can divide by 3 again, and that's 8. Divide by 2, that's 4. Divide by 2, that's 2. Divide by 2 and I get 1, so this is 3 times 2. And left under the square root, I also have a 3 times 2 because those are both left over. I've got a 3 that's left over and a 2 that's left over. So this is 6 square roots of 6.
What was it that can go in?
36. If you take this number and square it, it'll always tell you what number will divide evenly into it. Like on this one.
Right.
36 divided evenly into 180.
Oh yeah, it's just another one.
Okay, so that's stuff you've done before. Here's some stuff you haven't done before. Well, at least I don't believe that you have. When you have a whole number times a radical, we're just going to simplify the radical as usual and then multiply it times the 4. So for the square root of 72, maybe you can think of a perfect square that divides evenly into 72.
36.
All right. This is 36 times 2. So that's 4 times 6 times the square root of 2. It's 24 square roots of 2. We will be doing a lot of problems where we're taking something and multiplying by the square root of 2 or multiplying by the square root of 3. It's just going to happen a lot. When you have one like this, question?
No, I just think we have done that before.
Yeah.
Have you?
We have them.
Okay. So what is the square root of 2 times the square root of 2?
2.
2. So this is 7 times 2 is 14. So you've done that before?
Yes.
Cool.
I think we have.
It feels familiar at least?
Yes. So I think so.
When you have ones like this, well, there's not a lot we can do. That's 11 square roots of 15. And if we factor 15, it's just 3 and 5. There are no like factors, so that's not going to get any better.
Where'd you get the 15 from?
5 times 3.
Oh,
I just grouped these two together.
so then how'd you get the one above it?
What's the square root of 2 times the square root of 2? By definition, that is 2.
You just simplified.
I didn't even bother to multiply them together.
Yeah.
The square root of 17 times the square root of 17 is 17. I don't need to multiply them. Okay, that makes sense? So when they're alike like that, I can shortcut the process. For one like this, I'm going to show you 2 different ways that you can do this one. The first way is to do exactly what we've been doing. This is 12 times the square root of 45. Oh, we got lots of time. For some reason, I didn't think we had much time left.
Oh yeah, we do.
And then simplify the square root of 45. What's a perfect square number that divides evenly into 45? 9. And the square root of 9 is 3. So this is 36 square roots of 5. And that way works just fine. Feel free to use that. There's nothing wrong with it. It doesn't take a lot longer or anything. However, if you think about it a little bit, and I don't write all this out, I just think about it. I just think this is 12 times, and I break up the square root of 15 into the square root of 5 and the square root of 3. And what's the square root of 3 times the square root of 3? 3. And 3 times 12 is 36. Square roots of 5. If you can do that, it's great because it's a little bit faster. Grace, you're giving it the stink eye. What's up?
I'm kind of confused on how you did that.
What I did is I broke the square root of 15 into the square root of 5 times the square root of 3.
Oh.
And then I grouped these two together to get 3 times 12 is 36. Yeah, the square root of 3, if you want to do it that way, it's 19 times the square root of 3 times the square root of 2 times the square root of 2. That's 2 times 19 is 38, square roots of 3. It's a little bit faster. Not a ton, but a little bit. Okay. Last but not least, dividing and simplifying. So a simplified expression by most standards, although this one is beginning to get dropped by a lot of people in the math community, you can't leave a square root in the denominator. Okay? The reason for that actually predates calculators. If you're trying to divide by the square root of 2, which is approximately 1.414, that's ugly. If you can make it so that you have a whole number on bottom, so you're dividing by like 2, that's a lot nicer. Okay? So here's what we'll do. This is an example of the simplest kind ever. This is 17 square roots of 2 divided by the square root of 2. Whoop. That's 17. Sound effects are optional. Bloom. So let's try this one. If we've got 84 square roots of 15 divided by the square root of 3,
So 84 square root of 5.
yeah, it's 84 square roots of 5. Because 3 into 15 goes 5 times. And they're both square roots. I can reduce that way if they're both square roots or if they're both whole numbers, but not if it's one of each. Which leads us to this problem. 16 divided by the square root of 2.
Times
So you,
square root of 2 each.
so like,
Wait, hang on. Say it.
Times square root of 2 or like 16.
So multiply by the square root of 2 over the square root of 2. Let's stop before we do anything else. What is the square root of 2 over the square root of 2 equal to? 1. I'm multiplying by a form of 1. So I'm not changing the value. Okay? When I do that, in the numerator, I get 16 square roots of 2. In the denominator, what is the square root of 2 times the square root of 2? 2. Oh, that's going to get rid of the square root in the denominator. And now I'll simply reduce the fraction. 16 divided by 2 is 8. So that's 8 square roots of 2. We're going to do this so much, dividing by the square root of 2 and dividing by the square root of 3 and multiplying, most of you will get to the place where you don't even have to write a lot of this out. You can just do it in your head. You're going to have so much practice. All right, for this one, this is 23 over the square root of 3. Oh, by the way, I should have told you this. This process is called rationalizing the denominator. I wrote that really badly at the end. The reason it's called rationalizing the denominator is the square root of 2 is a number that is called an irrational number. Remember we talked about it being a radical, which is generally thought of as a bad thing? If you're irrational, that's usually thought of as being a bad thing. That's all in there in that same history together. Okay?
Is it rational, like good though?
Yes.
Yeah.
Irrational, bad. So the square root of 2, they're like, that's bad. It's irrational. It doesn't make any sense. It actually makes perfect sense, but we're stuck with the word. So to rationalize the denominator here, we'll multiply by the square root of 3 over the square root of 3. That'll be 23 square roots of 3 over 3. Fake bell number 2. And 3 won't divide evenly into 23, will it? So I'm done.
Oh, so we don't have to like make it a decimal or another fraction?
Or a mixed number? No.
Okay.
We'll just leave it in fractional form.
Nice.
All right, let's try this one. 42 square roots of 2 divided by the square root of 3. To rationalize the denominator, what should I multiply by? Yeah, and be careful. Don't just say multiply by the square root of 3. Let's be accurate.
Square root of 3 over the square root.
Yeah, the square root of 3 over the square root of 3. So that's going to be 42 square roots of 6 divided by 3.
14 to 6.
Yep. 14 square roots of 6. Sounds like you guys know this. You know the trick for divisibility by 3?
Yeah.
You can
You add them together and then
Add them.
wait,
Who are
add,
them?
Add the digits in the number
Yeah.
together.
Add the digits together. If that sum is divisible by 3, the original was divisible by 3 also. By the way, that also works for 9.
Oh, right.
If you add the digits together and it's divisible by 9, then the original was divisible by 9 as well.
When I divide by 9, I just do the.
Yeah, same.
The hand trick? Yeah. What if you're multiplying 9 times 15?
Oh well.
I don't think I've used it
You get a
since
friend?
5th grade.
I did it for
All right. I have a worksheet for you.